has now recording has now begun. All right, here's today's agenda. Again, as usual, entirely based on student submissions. The quality of the submissions is starting to improve. In the past, I've definitely had to reject the majority of submissions because they didn't conform to our guidelines. But apparently the guidelines we've been putting on here and on the website have had an effect. So these three made it onto the radar for today. Each of these three was actually mentioned multiple times by submitters. So that was part of the reason that we chose these three topics. As usual, we have mentioned this in previous study halls, but we'll take the first 3-4 minutes to just give you guys the usual warnings about what to submit and what not to submit, because some people are still submitting things that we can't use. So here they are. This is just what was on the board last time, but let's just go over this really quickly. The kinds of questions that we want: we don't want questions that are too general. We have sometimes historically had people coming in and posting things like, I want to know how to answer math questions better, which pretty much everything we say about quant ever could fall into that box. So that's not really something we could cover in one study hall. We've had people even say things like, how do I solve verbal problems? I mean, you see where we're going with this. That would be much, much, much too general to even think about. But at the same time, you don't want to be overly specific. We've had some people posting one problem and just saying, why is B incorrect and C correct? That kind of question is why we have forums. We remember that the same sources that you can post here, you can post on the forums, and vice versa. There's 100% overlap. If something is okay to post here, it's okay to post there, and if it is not, it is not. So if you have incredibly specific questions, then those belong in the forums. And then also the other kind of question that's not really appropriate, bear in mind these study halls are attended usually by between 30 and 50 people and are watched as recordings by several hundred people. So what doesn't make sense given that is to submit personal questions such as, this is my profile and here's my GMAT scores and here's where I want to go to school and what do I do. Not appropriate for this type of environment, for a group study hall. So please don't submit those here. Where you would send those, you would send them in the general folder, or if you have questions, you would send them, if you have questions about admissions in particular, you can also send them, you can post those in Ask an Admissions Expert for admission-specific questions. So we have two folders on there for that. We have the general questions folder, which is more like, how do I plan a study plan? Where do I go from here? These are my goal schools. This is the score I want to get, et cetera, et cetera. Ask an admissions counselor is basically just what it sounds like. You want advice on admissions. So those, again, do not belong here. Those belong in the forum. Also, people, sources. Really, guys, this is, at this point, this is probably the single biggest issue. We've had people posting problems and not saying where those problems are from. You can't do that. If you're going to post an actual problem with answer choices, you must give us the source. So you cannot submit a problem without telling us where you got it. Okay, if you submit a particular problem without a source, it'll just be rejected. Because remember, there are lots of copyright issues swirling around this industry, and so if we do not want to unwittingly steal some other company's questions. So please tell us where they come from. Also, when you submit the source of the problem, The other thing to know here is that other forums, such as GMAT Club or Beat the GMAT or these other sources, these are not acceptable as a source. Because forums are not really the source of the problem. I mean, forums are second stage. Forums are where people post problems that they got from somewhere else. So we need the original source of the problem. We can't take other forums as sources. So we need the original source of the problem, where, like, the people who actually wrote it. Okay, smiley face if you guys, this is the usual group of warnings. Give me the smiley face if you guys understand all of this. Okay, some of you, I recognize a couple names in today's audience of people who have been submitting specific problems with no source attributed. Just realize that we have to ignore those because they may be in violation of copyright. I mean, every long now and then someone will submit a problem that we recognize from GMAT prep, but that's rare. Like, usually when we get these random submissions, we don't know where they're from. Also, the other thing that's worth saying is that even if the source is Manhattan GMAT, you still have to tell us that, because we as instructors have not memorized the entire catalog of our own problems. I mean, there are several hundred Manhattan GMAT problems out there. In fact, I think if you count Klon and verbal, it's over 1,000. So even if we are the source of the problem, you guys must still tell us that. Because, yeah. Okay, let's go on to the actual material of the study hall. So the first topic for today is going to be determining content of prime boxes. As a brief warning to start, I'm reluctant to talk about such concepts as difficulty or whether something is harder than something else, because that's generally an experience that varies greatly from person to person. In other words, the problems that one person thinks are hard, another person will think are less hard, and vice versa. But generally, empirically, with my own private students especially, for some reason we tend to find that primes and divisibility is very hard for people. Even with a great deal of studying, a lot of people have a hard time improving this particular area. So the reason I'm telling you this right now is that some of the stuff we're about to do may be quite difficult for a lot of people here. But we'll start from relative basics. We will assume that you understand what a prime factorization is and how it works. If any of you are not our students, I'll give you a quick 30-second rundown of what a prime box is. So a prime box is our tool. It's our tool for depicting the content of a number's prime factorization. Right, for instance, the number 30, if you factor 30 into primes, I mean, you can start out by factoring 30 into 3 and 10. 3 is prime, but 10 is not, so you can continue to factor. 10 gives you 5 and 2. So the prime factorization of 30 is 3 times 5 times 2. Okay. What we do is we have this tool called a prime box, which takes this information and puts it into a pictorial form in which we write the original number 30 over the top of the box, and then in the box we put the prime factorization of the number. Now at this point you may be asking yourself, why would we bother? Because if you look at what we have here, it's pretty clear that you can do this without the prime box. I mean, in this type of situation, this factor tree is plenty good enough. Does anybody know, in the text box you can type, does anybody know why the prime box is so useful? As a hint, it has to do with the fact that most of the things we talk about in these problems are not hard numbers like 30. Usually when we discuss divisibility, we're talking about divisibility of what types of things. A couple of you are typing. See what you have to say. Okay, primes are building blocks of numbers. That's the fact. Yeah. What it's basically together what you guys are saying. We are talking about variables here. So if you have an unknown, then you're not going to be able to make a factor 3 out of an unknown because you don't know where to start the tree. So if I tell you something like n is divisible by 30, the prime box becomes a much more useful deal here. I mean, you can still draw an attempted factor tree. Like you can draw the factor tree where you would put a 30 here and then an I don't know what over here. And then we know from before that 30 works out to be 3 times 5 times 2. But our students find consistently that it's much more helpful if we use a box in this type of situation. So we would say n is divisible by 30. This time we know that there are prime factors of 3, 5, and 2. But this time there may also be other factors. So we put a question mark like that to indicate, because divisibility just means that these prime factors are contained in the factorization. They are in the box. But they are not necessarily the only things in the box. So in this case, n could have additional factors. As opposed to something like 30. I mean, 30 is a hard number, so 30 definitely does not have additional factors. Okay, these are the basics. Again, we're assuming a certain degree of familiarity with prime factorizations and how to factor things. If you are rusty on the concepts of prime factorizations, the next 40 minutes or so of material is going to be hard. But try to follow as best you can. Smiley face if this stuff up here makes sense to you. Okay, good stuff. So what we're going to look at, and then we're going to have a bunch of data sufficiency style exercises. We're going to look at the impact of these different kinds of statements on the prime box. So let's start out with a generalization. The generalization is this. When you consider the impact of a statement on a number's prime box, there are actually three things you should be thinking about. Here they are. The first one is what numbers, if any, must be in the prime box. What numbers, if any, may or may not be in the prime box. And then finally, what numbers, if any, cannot be in the prime box. Some statements are a lot more packed with information than others. So you may get a statement which, believe it or not, will actually supply answers to all three of these questions. But what we're going to do is take the foregoing statements and examine them one by one in regard to these three questions. But this is a nice takeaway for all of you. When you review your knowledge of prime boxes and divisibility and so forth, you should consider all three of these issues. Some of them may be answered, some of them may not. So here's an example. Let's take this first example. Divisibility statements. Let's take it over here. New screen. Here's your divisibility statements, and here's your 3 questions. Okay, so a bit of logistical action there. All right. So first, let's look at divisibility statements. Put these questions on each of those, and then we'll check it out. All right. So let's answer these questions in the text box. If I say n is divisible by 12 and n is divisible by 20, and as we go through this, we're also going to hit another hot topic here, which is how to combine statements like this. So let's take a look. If n is divisible by 12, then someone tell me in the text box what has to be in n. It must contain a 2, a 2, and a 3. That is correct. A couple of you are just typing 3 and 2. Make sure you know that the number of times that a prime appears is a supremely important consideration. In other words, there are 2 distinct 2's in the prime box, which is a factor for sure. Also, if someone typed 4, make sure you know that 4 is not prime. So the green statement means that n must contain both. N must contain 2, 2, and 3. What about this blue statement right here? What does that mean? Okay. Now, here's the kicker. It's a 2, 2, and a 5. That's 20 broken down into primes. How do we combine these 2 statements? What primes must be in the box? Let's see what you guys type. And if primes are repeated, yeah, again, make sure if primes are repeated, make sure you type them as repeated. So here's the story. The best way to think about it is like this. Let's say that someone's running away from the scene of a crime, and you have 2 eyewitnesses that watch this person run away from the scene. The first eyewitness says, I saw the person carrying 2 boxes and a can. The next eyewitness says, I saw 2 boxes and a bag. So we don't know that the person was carrying 4 boxes. I mean, these 2 eyewitnesses could well have seen the same 2 boxes. So a box, can, box, bag. All we know for sure is that there were at least 2 boxes, a can, and a bag. So done very well. Person who wrote, I think, all the 2's, give me a smiley face if it makes sense now why it's not all the 2's. Just as your 2 eyewitnesses might have seen the same boxes, these might be the same 2's. So like if you have separate observations, these are entirely separate observations about divisibility, then you must allow for the possible overlap between the observations. Okay, when you do so, you get the LCM, which is the least common multiple of the 2 numbers. For instance, this is just 2, 2, 3, and 5. This product is 60 if you multiply this out. That's the least common multiple of 12 and 20. You don't have to have more primes than that. Another way you can figure this out is just to start grinding out lists of numbers, which is something we'll see later. What numbers may or may not be in the prime box? Anybody in the text box? Please indicate. May or may not. You guys need to cast a wider net than you are casting right now. You could, the remaining 2s and so on. The answer to this question is absolutely anything else. It's totally possible that n is divisible by 641, which is a prime, or 6,700,417, which is a prime. It's totally possible. So, because all we know, again, if we go back to this statement over here, if we say n is divisible by 30, the point is just that n is 30 times absolutely anything. It's 30 times I don't know what. So in this prime box, we definitely have a 3, a 5, and a 2, but we could have an 11, a 17, a 641. We could have every possible prime that comes to mind. So smiley face icon if this makes sense to you guys. If n is divisible by 30, n could well contain anything, pretty much. Okay, there was one non-smiley face. We had about 20 smiley faces, so we're going to move on. If you were the unsmiley person, go ahead and try to post your question in the text box, and I'll try to nail it. Okay, so what numbers cannot be in the prime box? There are no numbers are disallowed. So the best way to draw this prime box in this situation is to say that n definitely has a 2, a 2, a 3, a 5, and then we don't know why. Okay, let's take a look at another statement. N is not divisible by 12. Okay, when you take a look at this, note that 12 is 2 times 2 times 3. Okay, are there any numbers that must be in the prime box? Okay, there are none, because all we know is that n is not divisible by 12. We're not told that n is divisible by anything. There's a person who posted a question in the text box about 30 seconds ago about the overlapping 2's. Whoever posted that question, I think, is fundamentally misunderstanding what is going on up here. Because the question said is because one number can be divisible by 20 and not 12. These are not 2 numbers. This is the same number both times, which is in fact, well, that was an accident. This is the same number both times. This is n and this is also n, but we're making observations about the same number twice. So it's not 2 separate numbers. Maybe check those notes again real quick and type a question if you get that. Okay, in this prime box, there are not necessarily, I mean, this n might not have any prime factors at all. I mean, it's totally possible that n could just be 1. So, none. Note that it's possible that, say, n equals 1, which doesn't have any prime factors. By the way, if whenever we talk about these things, it's worth noting that as a convention here, you guys can just, from now on, just assume that we're talking about positive integers in the divisibility problems. Okay. So, yeah, these email, no, we don't do as an email, but these things are going to be posted as recordings on the internet, so you will have access to those. Okay, if n is not divisible by 12, so we're going to assume that we're talking about positive integers, so we're not going to deal with the case of 0. You would treat 0 as divisible by 12, actually. 0 is divisible by anything, but the GMAT is probably not going to test you on that. Okay, what numbers may or may not be in the text box? So let's look at this statement very carefully. The statement means you do not, you don't have 2 times 2 times 3. That's what this means. So in this case, you can't really answer questions 2 and 3 separately because now they depend on each other. Basically, the deal is you just can't have all of 2, 2, and 3. Therefore, if you have 2 2s, then you can't have a 3. And if you have a 3, then you can't have 2 2s. So notice there are a lot more possibilities than you might think here. For instance, it's totally possible for you to have like 10,000 3s here, as long as you don't also have 2 2s. So for instance, you can have as many 2s as you want, as long as you don't have a 3. Similarly, you can have as many 3s as you want, provided there are not 2 2s. So yeah, you can have, and these questions that are in the box, these should be answered by these 2 possibilities. Can you have 1 2 and 1 3? Yes, you can, because you don't have all of this. Can you have that? Both of you are asking the same question. Okay. But notice that there are, like, a lot of people think it's just 2 and 3, or just 2, or just 3. And make sure you also realize you can totally have things like 10,000 2s and no 3. And you can totally have things like 10,000 3s and only 1 2, as long as you don't have this. All right, smiley face if that makes sense. If you're struggling with it a little bit, then still give the smiley face. The other face is mostly if this just doesn't make any sense right now. Okay. We didn't skip number 2. We answered them together because these, in this case, these questions interact with each other. Because what you can have depends on what you do have. For instance, if there are 2 2s, then you cannot have a 3. Otherwise, you can. It's conditional. If you have a 3, then you cannot have 2 2s. Otherwise, you can feel free to have 2 2s. So we're basically answering those at the same time. Okay, let's look at some exercises. What we're going to do is I'm going to throw these problems are crafted as data sufficiencies. Each of them should take less than 2 minutes because they are not complicated. So I'm going to give you about, I mean, they might be hard, but they're not complicated. Notice there's a big difference between the two. It's very easy to have a problem that is relatively simple, but is still difficult if it tests things that are easily confused. So, but these problems are not a lot of work. So let's try to do them in about a minute and a half. I'll put timers on the board, and then I'll post your statistics. And after we go over all 4 of them, then we'll review them. So try this. Okay, by the way, here's the way this works. If any of you are new to the study hall, the way the questions work, I'll put you on a timer. Wow, that font is very small. Let's make that bigger. Okay. I'll put you on a timer. You will see polling options in the corner of your screen. So I'm going to give you those right now. Those should have just appeared on your screen. Okay. Do not answer the questions in the text box, because everybody will see that. The point is that everybody is not supposed to see everybody else's answers so that you guys don't influence each other. And then when the timer expires, please guess. Because remember, that's the way the GMAT works. The GMAT requires you to answer a question if you want to move on. So if you run out of time, even if you have absolutely no clue what you are doing, you still have to guess. So just to make sure we're all on the same page, everybody pick D in the box at left, D like dog. Let's just make sure that we're all on the same page here, and then I'll clear you guys out. Okay, there are only about half of you so far who have picked D. Everybody make sure you do this. There are still about 10 or 12 of you who have not. Please pick choice D just to show me that you understand how the answer boxes work. Okay, good. There's about 3 of you who haven't yet. I'll assume you guys have stepped away from the computer. All right, here's the first problem. It's a data sufficiency problem. By the way, as usual, we are going to assume that you understand how data sufficiency works. So if you don't, I just cleared your answers. If you don't understand how data sufficiency works, then you're going to have kind of a hard time here. You should probably check out one of our recordings on that first and then come back. Here's the first problem. I'll put you on a timer for a minute and a half. Okay, if you have not picked an answer, please pick an answer. There are a number of you, most of you seem to be in the middle of the alphabet, who have not yet picked an answer, so please pick one. 5 seconds, I'll go ahead and publish the results to the board. And 4, 3, 2, 1. Okay, here we go. So split decision mostly between C and E on this one. Now, we're going to come back to this in a second, but what I want to do is I want to address the idea of a product, because a product is not the same thing as what we've been doing. Like, I kind of wanted to get an idea of how good you were with this concept at first before I gave it to you. But let's take a look at products. So here you go. And we'll come back to this question in a second. So if n is divisible by 12 and m is divisible by 20, then what are the known prime factors of mn? Now notice this is different. Okay, now we're actually talking about 2 different numbers. Very important. So this is n is divisible by 12, and m is divisible by 12. Notice this is different, okay? This is n is carrying 2 2s and a 3. And this is M is carrying 2 2s and a 5. So back to our analogy with the 2 eyewitnesses type situation. This is like one eyewitness saying the first suspect was carrying a box, and a can. And the second suspect was, and someone other eyewitness said the second suspect was carrying a box, and a bag. In that case, we have 2 different people who are carrying these items. We have N carrying these items, and we have M carrying those items. So when you multiply these 2 numbers together, you really do just throw everything in their prime boxes together. So if you multiply 2 different numbers, then you actually do throw everything in their prime boxes together. So in the prime box of Mn, you've got everything you've got in M, and you've got everything you've got in N, and it all goes over. So Mn must contain all of those things. So from the M, you've got a 2, a 2, and a 5. And then from the N, you've got a 2, a 2, and a 3. So all of that goes in. All right, smiley faces if that makes sense. Again, I mean, the analogy of the eyewitnesses is probably the best way to think about it. Because again, you want to think about it in terms of, all right, like this is saying the same suspect was carrying these items. So we can explain it in that way. N must contain 2, 2, and 3 in this example meant the suspect was carrying a 2, and a 3. In this case, you had a different eyewitness saying the same suspect, the same person, was carrying a 2, and a 5. So in this case, these could overlap. These could be the same 2s, so you cannot say there are more than 2 2s. In this case, though, you've got 2 different people carrying these things, so they're different. So they all go into the prime box together. These are just straight up statements about divisibility, so the other 2 questions work the same way. What may or may not be in the box? Absolutely anything else. And there's nothing prohibited. So, given this, let's take a look. The problem here is the following. Let's go ahead and discuss this on the next page. Statement 1, okay, statement 2 is definitely not sufficient because it doesn't tell you anything about M. One person indicated answer choice D. I'm assuming that that person probably confused what D means with what C means. Because D would mean that both of the statements individually were sufficient, which is definitely not true here, because this statement's not going to do the job. Statement 1 says that when you throw all of the contents of M and N together into a prime box, you have 40, which is 40 is 4 times 10, which is 2 times 2 times 2 times 5. So that's 2 times 2 times 2 times 5. Okay, so this means that when you throw all of m and n together into a box, you have 2 times 2 times 2 times 5. But it doesn't say anything about which of these things came from m and which of them came from n. Okay, so if we go back to our example of the product over here, the product prime box is formed from these two guys. So everything in here has to come from one of those places. But if I just gave you this, then you would have no idea where those numbers came from. You would, I mean, they're color-coded right now, but if they weren't, then you would have no idea which of those came from m or n. Smiley face if that makes sense. Okay, like if I just told you this, it's very possible that m could contain all of these numbers and that n has nothing. I mean, n could be 1, or n could just be some random number. So, keeping that in mind, statement 1 is not sufficient. But if we have them together, let's take a look at them together. So we know that m and n thrown together, this is where the prime box issue makes itself really useful. Because doing this with a tree diagram is pretty much impossible. So m and n thrown together contains at least a 2, a 2, a 2, and a 5. And then we don't know. Notice that we know this has to come from m and from n. So this is m, this is n, and these are the two things that are making up that. So we know that n is divisible by 5, because that's given. And there are question marks here, and there are question marks here. The deal is that we've got to get these 3 2's from somewhere, but we don't know where they are. I mean, we need, these are what's missing. So those 3 2's have to come from somewhere, but we don't know where they come from. So the 3 2's are somehow distributed between these guys, but we don't know how. So, text box, please, what should the answer to this question be? It should be E like elephant. So, people who picked E, you guys are the winner. All right, let me make that a highlight color box. Good stuff. Okay, by the way, this is where I want to tell you guys about a backup method. All right, first I want to point out that, what I pointed out at the beginning of this study hall, which is that these things are hard. Okay. Therefore, since they're hard, it's nice to have a backup method. Here's what that is. Basically, if you aren't understanding how the prime boxes work, then just forget about the prime boxes and just start trying to find numbers, like regular numbers, like specific numbers that can answer the problem. Okay, for instance, let's say you've got, we need to do a little bit of moving things here. Okay, let's say you're looking at this problem. If you look at these two things together, I mean, okay, statement 2 is definitely not sufficient, so let's get rid of that. Let's try statement 1. In statement 1, the deal is mn is divisible by 40. When you investigate a data sufficiency problem, you should try to prove that the statements are insufficient. See if you can get 2 different answers. So when you do this, I try to get 2 different answers. So this is a yes or no question, which means we're trying to get a yes and a no here. So if we do that, statement 1, well, if m and n are 1 and 40, that's a yes to the question. Or that's a no to the question. And then if you reverse those numbers, then that's a yes to the question. So not sufficient. Smiley face if that makes sense to you guys. Because in a lot of these cases, you're going to have a much easier time just playing around with numbers than you are trying to figure out this prime box stuff. The general deal here is that you have to be very trigger happy. If you do not immediately have a pretty solid understanding of what is going on here, then you should just start doing this. Start throwing numbers at it and just watch what happens. If you have the 2 statements together, then so now n has to be divisible by 5. So if n is 5 and you make m 8, then that's a yes to the question. But then you can still take this outcome here and just use it again from before. I didn't mean to do that. Pardon me. Okay. There. If you just redo that case from before, then you get a yes and a no to the question. So this is still not sufficient. For a lot of students, this is going to be much faster. In general, you should try the prime box approach first because you never know whether you're going to be able to find these numbers or not. But, you know, because, okay, if a statement is insufficient, you may discover that very quickly, like we did here. But if a statement is sufficient, I mean, you can never really prove that a statement is sufficient by picking numbers. That's the problem. So, like, it's going to take you, the only way to determine if something is sufficient is to go through tons and tons and tons and tons and tons of possibilities and just keep doing the same thing over and over again. So you should try, yeah. I mean, you can quickly eliminate statements here because it's got nothing to do with the question if you have it by itself. Okay, good. Let's take a look at another question. Let's take a look at this one's going to be probably a little easier for you guys, but you never know. Try this one. It's this one that's right here. So I'm going to clear out your answers and give you a timer and go for it. Please answer it don't answer the text box. Answer it on your letters. Okay, please pick an answer. If you don't have one, there are about 6 of you who don't. So please pick something shortly. Thank you. Okay, here are your statistics. If your answer is registered, you should see it on there. Your answer was registered. The person who posted that question. I can see your answer. All right, so here's what you guys put. You guys put C and E overwhelmingly. Let's grab this question and make a separate screen out of it. So here we go. All right. So let's take a look. Well, this is the same number n. So 40, here's the prime box method. 40 is, again, 2 times 2 times 2 times 5. So statement 1 is, the question is, does the box have 2 times 2 times 2 times 5? Statement 1, it's supposed to be a parenthesis. Statement 1 says that there is a 2 and a 5, and then maybe other stuff. So there may be a 2, a 2, a 2, and a 5. So that's insufficient. Statement 2 is the same sort of deal. This is n. N contains a 2 and a 2. And then we don't know what else. So this may or may not contain 2, 2, 2, and 5. So that's insufficient. Looks like you guys realize this because none of you picked A or B. But if you pick these together, then let's talk about how to do that. In this case, these are overlapping observations. Okay, so eyewitness number 1 says n is carrying a 2 and a 5. Eyewitness number 2 says n is carrying a 2 2s. So how many, go ahead and say in the text box, how many 2s does n have to be carrying? Make sure you think about people literally carrying things. I mean, assuming these eyewitnesses are not lying or they didn't see illusions. I mean, if eyewitness 1 saw 1 bag in the guy's hand, and eyewitness 2 saw 2 bags, we know there are 2 bags, but we don't know there are 3. But the presence of these 2 bags is not an illusion. There are definitely 2 bags. So, but just 2, not necessarily 3. So we know that there are just 2 bags, 2 2s. And then the 5 is there because one of the eyewitnesses saw that too. But that's it. So, still don't know. So that's still insufficient. So this has got to be E. Does that make sense? Smiley face if it does, please. Smiley face if that makes sense. All right. Also, you can also just pick numbers. If you just pick numbers like statement 1, if you just pick 10, then that's a no. But if you pick 40, that's a yes, so that's insufficient. Statement 2 is 4 would give you a no, but if you pick 40 itself, you get a yes. So that's insufficient. If you have them together, you just need a number that is divisible by 4 and also by 10. So the first number that does that is 20, so that's a no. The next number that does is 40, that's a yes. So still insufficient, that's E. Notice that these numbers should not be very hard to find. Like if I just randomly asked you for a number that 10 and 4 both go into, you should be able to give me 20. Whether or not you understand the theory of the least common multiple, you should still be able to spit those numbers at me. So if you guys are too hung up on the prime boxes, those of you who picked C, make sure you are investigating this avenue of investigation. Okay, let's look at another one. Let's take a look at this one right here. In fact, let's look at 2 of them. Okay, try this one. We're going to do them one at a time. I'm going to clear your answers. Try this one. Nicole, for it to be sufficient, technically you need an infinite number of yeses or nos. So sufficient would be you just keep getting yeses until you are convinced that that is all you will get. Because if you get 19 yeses followed by a no, that's still insufficient. So that's the one thing that's rough about number picking is that you can never be quite sure of sufficient. Insufficient you can be sure. Sufficient, not so much. Okay, try this. I'll give you about a minute 10 or something. We're in blabbing for a little bit. Okay, go for it. Okay, people, let's pick something, please. There's only 2 of you who don't. I think one of you is a duplicate user. So here's the answers. Overwhelming majority of C, but we'll discuss in a little bit. And then here's the last question. So try that one, and I'll reset your answers. Give that a shot. Thank you, guys. Appreciate it. I was off the mic. Okay. For the, don't hesitate. If you can't hear, don't hesitate to write in the text box. For this problem right here, you guys almost all got this right. Notice it's different from this one. So these 2 are meant to illustrate that it's not always, you can't just memorize what happens here. So in this case, here's your stats. And you guys are absolutely right. Still 40 is 2225. This is a 222, we don't know. This is a 5, we don't know. Together, though, this time there's no overlap. There's nobody carrying the same thing here. So if one eyewitness saw 3 2s and another eyewitness saw a 5, then we know we have this stuff. So this is sufficient in this case. This is C. If you're going to pick numbers for this sort of possibility, then statement 1 would be something like, well, if n is 8, then that's a no. If it's 40, that's a yes, so that's insufficient. Statement 2 would be something like, if it is 5, that's a no. If it's actually 40, that's a yes, so that's insufficient. It does, yeah. I mean, but notice that all of these paths are paths to the solution. So, I mean, shortcuts, a comment here, by the way, guys, about shortcuts. Do not try to use shortcuts unless you already 100% understand all of the theory. Because otherwise, because remember, this test is all about trying to knock people in the head who try to use shortcuts. So shortcuts are not a good idea if any of you are shaky on the theory. You've got to first try to understand what actually happened in the problem. If you have these together, the first number that does both of these is 40. The next one is 80. The next one is 120, etc. Now the deal is this is still not 100% proof, but there's a clear pattern here. So you can pick sufficient. I mean, keep in mind that whenever you pick sufficient based on picking numbers, you can never be 100% sure. But in this case, we've got a clear pattern. All right, smiley face if this makes sense. Well, not when you have two different numbers, as in the case we're going to look at next. So here's the last case, which is this one. The last problem is right here. So in this case, okay, we want to know, does the product have 2, 2, 2, 5? Remember about the products, remember with the product is formed by just throwing together everything. No LCM in this case. So, okay, statement 1 and statement 2 are still insufficient for the reasons that we've talked about before. But if you have these together, then M contains in its box a 2 and a 5, and then a bunch of question marks. And then N contains a 2, and a bunch of question marks. So, and then let's put those in different colors just for emphasis. And then if you've got those, then notice that the product MN is definitely going to be made by throwing those together. So that's going to be a 2, a 2, a 2, and 5, and other stuff. So, and even, you know, even the question marks, whatever the question marks are, even those get thrown in there too. So there you go. So that's sufficient. You can also do this by number picking. If you want to look at that real quick. If you have the two statements together, let's just skip to that, because that's all you guys were looking at here. If you have the two statements together, just you make separate lists for M and for N. So M could be and N could be. Okay, M could be 10, 20, 30, 40, and so on. And N could be 4, 8, 12, 16, and so on. If you try products, all of the products will be divisible by 40. So after a while, you give up on trying to get it down. Or you just try all the different possibilities. 10 times 4, okay, yeah, it's divisible by 40. 10 times 8, yeah. 10 times 12, yeah. 10 times 16, yeah. Okay, 20 times 4, yeah. 20 times 8. And so on. You're going to find that everything you try winds up being divisible by 40. So again, you don't have to understand the theory if you just want to go plug in a bunch of numbers. All right, smiley faces if this stuff makes sense to you guys. All right. Now let's try something more fun. You guys want to try something more fun? Let's try something like this. Okay. I'll give you about a minute 45. Go for it. Okay, please pick some answers to this. This looks pretty good, actually. Take about another 10 seconds, please. Okay, let's show your answers to this one. Here they are. Okay. All right, so let's take a look. How many hours is totally not a question I can even start to answer. I mean, especially with these quant concepts. I mean, quant concepts that take one person 10 hours sometimes take somebody else 1 hour. And then what's weird is that the next concept will be exactly the other way around. The next concept will take the other guy 10 hours, it'll take the first guy 1 hour. So it's not even something I could even attempt to give you an honest answer to. Okay, let's take a look at this one in terms of prime boxes first. So if we do, note these statements are a little bit harder to deal with. Statement 1 says that you cannot have hold on a second. Okay, let's put this on another sheet. Statement 1 says that you cannot have a 3, a 3, and a 5, because that's what 45 is. Okay, on the other, so what this means is you can either have 0 or 1 3s plus any number of 5s plus anything else. Or you can have any number of 3s plus no 5s plus anything else. Because the deal is just you can't have both of these, but you can totally have one of them. You can have any 3s you want as long as you don't have the 5, and you can have all the 5s you want as long as you don't have both of the 3s. You just can't have the total combination of all of this. So 27 is 3 times 3 times 3, so this, if you have this sort of situation, this would be a definite no to that. But this could go either way. So this is insufficient. Smiley face if that makes sense. Okay. All right, so that's a good number of smiley faces. Statement 2 says you cannot have, it's very similar analysis. Statement 2 says you cannot have 2 3s, and a multiple of is the same thing as divisible by. Those are exactly the same thing. You cannot have 2 3s and a 7. So this means you have 0 or 1 3s plus any number of 7s plus anything else. Or you can have any number of 3s plus no 7s plus anything else. So same thing with the question. You can still have, this is a definite no, but this is either yes or no. And if you have the statements together, we need conditions that satisfy both of these. So you can, like, we need some sort of condition that does both of these guys. So if you have 0 or 1 3, then notice you are allowed to have any number of 5s you want, and you are allowed to have any number of 7s you want. But notice you got to make both of the statements true. So if you have 2 or more 3s, then this means you are not allowed to have 5s and you are not allowed to have 7s. So let me change that to any number of 3s. It's just assembling these two statements together to make them both true. So any number of 3s plus no 5s plus no 7s plus anything else. So in that abstract, this is still a no to the question, and this is yes or no. In this case, it's probably easier to pick numbers. Statement 1, if you just pick 1, then that's not a multiple of 45, and that's a no to the question. And then the first thing, remember what we're doing. If you get a no, now you have to try for a what in the text box. As soon as we get a no, we're trying for a yes. So if you get a 1, that's a no. Let's try for a yes. The easiest yes I can get is by picking 27. So that's insufficient. Statement 2, you can actually use the same numbers. And believe it or not, for the two statements together, you can also use exactly the same numbers. So this is one of those problems that you can just sneak in the back door by picking in numbers, and you can solve the whole thing. And, I mean, if you pick numbers on this guy, you can solve the problem in like 20 seconds. So there. Okay. You can't really do any less analysis than this, unfortunately. Because not a multiple of 45 doesn't mean the opposite of each individual condition. For example, if I'm tall and have dark hair, then if you're not me, that doesn't mean you have to be short, and it doesn't mean you have to have light hair. Same kind of thing here. I mean, this is the shortest way to answer that right now without spiraling off onto a lot of tangents is to say that this is pretty much the least amount of analysis that you can do here, unfortunately. Okay, let's look at a slight variant of this problem, which is that one. Right there. Go ahead and try that. The second one. I'll give you another minute 45. Go for it. Okay, go ahead and pick an answer, please. If you have to guess, then guess. Part of the reason we're allotting you less time than you would get on the real GMAT is because we're doing a whole bunch of the same topic in a row. So it's not legitimate to allow yourself the same amount of time when it's a topic that you're already sort of primed for. That's the deal. All right, if you're here and you haven't picked an answer, please pick an answer. Thanks. Okay, I'll give you about 3 more seconds to select your answer, and then we will go. 2, 1, there it is. Okay, so this one's a little bit more interesting. We were actually evenly split between C and E. So let's take a look. Here's a page for this problem. All right, is L divisible by 27? So we can import the analysis of statement 1 from the other problem. So let's do that. And then we can also import the meaning of the question. Okay, so statement 1 is still insufficient. One person put D. I don't know if that person just arrived, but we just saw the same question and the same statement in the last problem, and it was insufficient. So if you picked D, then that means you thought it was sufficient this time. It's the same statement. So if you are the person who picked D, that probably means that you need to go back and review the basics of data sufficiency and just make sure you understand what these choices mean. But yeah, okay, statement 2. Let's import the number picking method for statement 1 from this problem. So all of that is still the same. That was interesting. Okay, this, and all right. Let's look at statement 2. Statement 2 says that L contains at least 1, 2, and 1, 5. So this is, if you want to draw a prime box for this, then this is 2, 5, and then question marks. So this may, those question marks could totally have a bunch of 3s in there. So we don't know. So that's not sufficient either. If you want to pick numbers for that statement, you can pick 10 itself. That's a no. How would you get a yes? Who can give me a number that's divisible by 10 and 27? Yeah, 270. So you can just come up with that number. So insufficient. And if you combine these statements together, then let's note what happens. Let's note what is still possible here. Let's number these possibilities. Let's call that A and B. So the problem here is if you have a 5 in there, then this possibility is not possible anymore. So because there is a 5, so you can't have this. Therefore, it's got to be possibility A. So that's sufficient. That's a no to the question. So if you look at, or you can look at it as a prime box. So let's do that. We know we've got this prime box right here that has a 2, a 5, and a bunch of question marks. But we also know that there is not, it does not have 3, 3, and 5. Well, we have the 5. So this makes this statement a lot more specific than it used to be. We have the 5. We don't have 3, 3, 5. That means we don't have those 3s. So we either have 1, 3, or we have no 3s. So the answer to this is a no to the question. All right, smiley face if that makes sense. Okay, mostly smileys. Thank you, I appreciate it. If you pick numbers here, then let's see how to do that. If you have the two statements together, probably the best way to do this, because there are lots and lots of numbers that are not multiples of 45. So take the multiples of 10 and cross out the multiples of 45. So if you do a number picking method, you should have time to do this sort of approach. I mean, it's not something that's going to happen. I mean, again, you guys, you cannot leave number picking for dead last. Like, you have to decide that you're going to do this pretty early, because in the case of statements like this, I can't type numbers today. In the case of statements like this, you're going to find that you have to try these earlier than you think, because you're going to have to generate lists of numbers. This is the downside, because those two are very hard to combine when you do number picking. So we just have to settle for looking at a bunch of numbers. So here's the first ones up to 300. And then the ones we don't want, the ones that are multiples of 45. So 90 is out, and 180 is out, and 270 is out. We're going to keep crossing out 360, 450, and so on. We're going to cross out all the yeses. So that's a definite no, and so that's sufficient. It's not easy to see that in this case. This is not the world's easiest number picking method. But if you decide at the beginning of the problem that you don't know how to handle these otherwise, then this is what you do. Okay. That's it. We're actually starting to roll, believe it or not, we're actually starting to roll over time here already. So we had a couple of problems left to go here, but what I'll do is I'll just show you the problem, and I'll tell you what the answer is, and then we'll leave that as an exercise for the reader. In other words, you're going to, we're not going to go over it because the study hall is over now, but I'll give you the problem, and then I'll give you a fun bonus fact as well, and then we will let you out. So yeah, the answer to this is C. Thank you. Because the two statements together are sufficient. So this one you want C. We'll leave you with a fun exercise for the reader. This problem is not easy, but remember that you can attack it with either number picking or prime boxes. So make sure that you, this is not easy. Try number picking if you are stuck. Okay, the answer to this is going to be B. So see if you can get that to work out. And then here's a fun bonus fact about these things. We're not going to use it in any problems, but if you take any two integers, yes, the question in the text box, yeah. For C, if you have them together, you get a solid no. Okay, if you take two numbers and you multiply their GCF by their LCM, you actually get the same as if you just multiply the two numbers together. This is kind of a cool fact. The chance that you will get to use this fact is pretty close to nil, but if you get to use this fact, it may take like an entire problem and let you solve it immediately. So it's kind of neat. It's one of those kind of long shot facts. But okay, so thank you for attending, and these two topics that we indicated here at the very beginning, will be put over to future study halls. So let's mark that for future study halls. There it is. These things we are going to cover in future study halls. Okay. Let's kill the recording. The recording is now